Hi, today I have this Marantz PM-50, which is my personal amplifier for everyday use. It's not the world's best amplifier, but for me it basically is, because it's mine and I'm really used to it and I really like the sound of this. And yeah, it just completely blew all the transistors, the power amplifier transistors. And I have a suspicion that I know where the fault lies. And I bought all the spare parts I need to hopefully fix this. So let's get it on, I say. So here's what I suspect is the culprit. This little STK chip here is used in this as a preamplifier stage, or as the preamplifier stage. And these things are running quite hot normally, but in this unit this runs really hot, I guess. So hot that, yeah, I guess there's something severely wrong with this, and I'm gonna replace it with a better one. Basically, you can replace these STK 3062 revision 4 with the 3082 revision 3, which is the same STK package, but with a higher rating, with a higher output rating and a higher input voltage, but it will work with the lower voltage that it receives in this circuit here. So it's most probably it's gonna be a very good replacement for this and will run a bit cooler than this and maybe last a bit longer. I guess everything else is fine here. I'll check some of the transistors, the power transistors. I thought these were all blown, but I think they are just fine, maybe. I think the only thing that's blown is this thing, most probably, because I checked this and even the relay clicks and everything seems to work fine, but yeah. This thing here, all it gives is a crackling sound, and the crackle does not react to the volume pot, so it's most probably something in the output stages of this thing here that is amplified by the transistors no matter what. Yeah, so let's, I guess, turn this unit around and see if the transistors are still good. So here we are basically inside the main circuit board in this unit. It just has a little service door here that you can unscrew, and you have access to all the transistors and all the solder joints here. So I guess I'll just have a closer look. So let's put this on the continuity tester and just see if the outputs are shorted. No, that was just me slipping. Okay, this one's bad. Okay. This one is definitely bad, so give it a little dot there, I guess. This one is bad, so we have to unsolder this. So yeah, let's do that. Let's fire up the desoldering station, I guess. I have that standing on the side here. And as you know, you saw that in the other videos I used this. It takes a while. So I have one of those transistors pulled, and I suspect that the one on the other side, the one corresponding to this, is also a cactus. Let's pull the one on the other side here as well. So, by the way, I ended up using this cheapo bicycle repair tool, multi-tool, for unscrewing those, because I can't get in there with the proper screwdriver, because the distance is too short so that you could reach the angle that you need to get any force on the screws here. And you need quite a lot of force. This is not easy. So let's turn the camera off. And I think I'm just gonna exchange both of those because I have the spares anyway. And I'm also gonna desolder the STK because this is crap anyway, and I'll replace it with the supposedly better model. And I still suspect that this is broken and broke the transistors. So yeah, let's do that, I guess. And the circuit board is really not that great. It's really... the pads rip off really easily. There, one pad came loose there. So maybe that was the whole fault there. So I suppose we'll have to make one little botch wire there. So here's the STK, and I should be able to just pop it out there, I guess. Let's see how this heatsink thing... Does it just come off? I suppose so, yes. Just lifts out. There it is. The little STK. And here's the replacement one. STK 3082 Mark III. And this is an STK 3062 Mark IV. But they are interchangeable. So you can pull this out through the wider portion of this hole with I used this with a pair of pliers, or maybe even by hand. So now this should just lift out, I guess. With the help of a little force. It's just stuck on there by some heat grease there. Yeah, so that's the old STK. Let's attach the new one, I think. But first clean the old paste off here and apply some new. So I have this all cleaned now with the help of my favorite isopropanol alcohol, and I'm gonna apply a bit of new paste here, new thermal compound. So, yeah. Not too much, that's already a bit much, I guess, but let's see. So this should just fit in here perfectly, I guess. Yeah, it does. So yeah, it was definitely a bit much solder paste, grease there. What is it called? Thermal compound. So we'll insert this again. And it snaps in place. And yeah, there we go. Let's reinsert it. There's a bit of thermal compound coming out the bottom there, but that's okay. Now it goes back into the board. Hope it fits. Yeah, I think that's in there. If my camera would focus, you could see it. So yeah, seems to be inserted quite nicely there. So let's solder it in and build a little botch wire for the pad I chipped off. So I heated up my soldering station and I'm gonna solder this in, the STK, the new one. And there we go. And we just need a little botch connection there to make sure that this pin still has contact. And then I'll just solder this on now. And this on here. So let's check if there's some nasty short in there. It's the multimeter. No, and is there a connection to here? Yes, there is. Alright, that should do it. So let's replace the transistors. Here's all the new transistors. So let's see how we're gonna do this. I'll just take the old transistor and see where it bends and bend this accordingly, I guess. So let's see. Yeah, that looks quite good. And we'll have to chip them there. So I'm clipping off the leads. So I clipped off the leads all at once. And I guess I'll screw it in and then solder it. It's probably a much cleaner method. Yeah, I got the screw in again with this little tool here, which I repurposed to be an audio tool, so to say. This is not a bike at all. But the tool still worked here. Maybe I'll get another screwdriver that is shorter. So we should have enough contact there. So let's try the other one. So I have all the connections checked and resoldered, and the new STK is in there. And I only changed the NPN transistors because they seem to measure bad. I'm not sure what happens, but I'm gonna try and turn this on. But I'm using the isolation transformer where I can regulate the voltage so that it most likely won't hurt that much if anything goes horribly wrong in there. So let's see. So I have plugged this into the isolation transformer, which is regulated to have 115 volts approximately coming out of it. And yeah, I'm not really sure what this does, but let's give it a shot, I guess. Maybe this smokes. No smoke so far. Let's see if the relay clicks. No, the relay is not clicking because I haven't got the speakers on. But it doesn't smoke, so let's activate the speakers, I guess. And turn it on again. And see. No, it doesn't smoke. Oh, there was a relay, I heard that. Yeah, the relays just click just fine, I think. See if there's anything that's getting hot. No. Wow, so this seems to be promising. I guess we'll try and give it the full juice, I guess. So I have hooked up my tablet, playing some funky Jan Beta theme music now. And I have this running on approximately 170 volts, where it should run on 230. And yeah, I'll just turn this on and see what it does. Let's see. And it plays the music. Oh, that's good. So, I suppose this is working. Let's try this on full voltage. So, let's see. This is full pull, full voltage. Let's see if it burns or stinks or explodes or anything like that. No, the relay just clicked. A bit harsher than before. And we have sound. Which is great. So this most likely works again. Whew. So that was most probably all that was wrong with that. So let's yeah, we'll have to adjust the idle current. Yeah, what we're gonna do now is to adjust the idle current of this. You always have to do that if you change the power transistors, or yeah, most likely even if you change the preamplifier stage, whatever it is, in this case the STK. And I guess this has significantly different output from the chip that was inserted here before. So let's adjust the idle current. I'll get out the service manual on my computer and yeah, let's see. So I opened the service manual. Let's see. Idling current adjustment. Before switching the power on, set the master volume control to the minimum position and the balance and tone controls to the center positions. Blah blah blah, to the center positions. Cement resistors, 3 test points, blah blah blah. Power on, just 14 millivolts we want. Alright, I think, yeah, we have to run it for 4 minutes or so and adjust the current to 14 millivolts that we can measure on the cement resistors. So let's see how the real thing looks. So the cement resistors are these things, and you basically take take your measurement on 2 terminals here, and you adjust this little screw here, which is the adjustment of the idling current for both channels. So you have to do it separately. This is the left channel and this is the right channel, and yeah, that's basically you leave this on without loudspeakers connected and with the volume to 0 and everything on 0 basically, and then you adjust the current, or in this case you measure the voltage, but it's really about the current that these transistors get. So I've connected my test leads to the extremities, that means the outermost pins on this cement resistor, and I'm going to turn this little screw until the voltage reading I get is about 14 millivolts. You will most likely not get it perfect, but yeah, the closer the better. So let's see, I guess. Let's turn this on and let this run for 5 minutes, and then we'll check the voltage. And I'll adjust it on the go a bit. You can see this. So I'll just leave this running for some minutes, 5 minutes or 10 minutes, and see if I can adjust the current so that it stays at a stable 14 millivolts. So I have the right channel adjusted to 14.3, which is quite close. Considering that these little adjustment pots are really flimsy, and yeah, basically if you make only a very small movement, the millivolts change significantly. So yeah, it's very hard to adjust those. But yeah, let's try with the second channel, the same procedure, I guess. So let's see here. And adjust it a bit. This behaves quite differently to what it did when the old chips were in there. So I guess that's good because it was broken before. I guess the transistors are drawing the right amount of power now. I hope so. 14.2. Now that's 14.3. That's as good as the other channel, I suppose. So let's listen to some music then, I guess. So this is up and running again. Thanks for watching. I'm Jan Beta. I'll link in some stuff in my end screen so you can support me, and also below in the video description. Thanks for watching. See you next time. Bye.